Hello, Algebra 1 students. So we have been talking about how to solve equations in this chapter, and we've talked about one-step equations and two-step equations. Well, sometimes equations have more than two steps, so we call those multi-step equations. So what I'd like for you to be able to do by the end of this video is to be able to solve multi-step equations by doing that thing that we do all the time, isolating the variable. So when it says solve an equation, that's the goal. You want to isolate the variable. Now with these multi-step equations, sometimes one of the steps is something called combining like terms. So before you do any type of inverse operation, typically you should combine like terms. Now remember, when we're combining like terms, they have to be the same letter with the same exponent on them as well. So here in our first example, it says combining like terms. What is the solution to 11m minus 8 minus 6m plus 22 equals 0? Well, the first thing I'm going to do is look at my like terms. So I have 11m and negative 6m. Remember, you're looking at the sign in front of the term and then read what you have. So 11m minus 6m. That gets me 5m. Then I have, I'll highlight it in different colors so you can see it. I have negative 8 and positive 22. So now I have negative 8 plus 22, or you can think of it as 22 minus 8. That's the same thing. So that's going to be plus 14. All that's equal to 0 still. Okay, now I have this down to a two-step equation, so I'm going to do order of operations in reverse. So I'm going to subtract 14 from both sides. So that gives me 5m is equal to negative 14. Then I'm going to divide by 5 on both sides. I'll bring my work up here. Negative 14 and 5 cannot be reduced. Don't turn it into a mixed number. Instead, just leave it top heavy, and we're going to say our answer is negative 14 over 5. And that's our solution. Okay, now it says solve for this one. So 5 is equal to 5m minus 23 plus 2m. First, combine any like terms that you see. Now keep in mind, those like terms do have to be on the same side of the equal sign. So I have 5m here and 2m here. It's a positive and a positive. So I have 5 is equal to 5 plus 2 is 7, and then your variables along for the ride, minus 23. Whoa, 3. There we go. Now I'm going to start isolating my variable. So I'm going to add 23 to both sides of the equation. And that gets me 28 is equal to 7m. Divide by 7 on both sides. I'll bring my work up here. 4 is equal to m. And I'm done. All right, next we have everybody's absolute favorite. We have a word problem. But, just like what I've been saying in class and all the other times we've done notes, read the problem more than once and break down the information and organize it so you know what it's telling you. So it says, concert merchandise. Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts but no bumper stickers. If Martha's total cost is $67, what is the cost of 1 shirt? Okay, usually this last sentence is letting us know, like in most word problems, the last sentence is letting us know what the variable of the problem is, what the unknown is. We're trying to find the cost of 1 shirt, so we'll call that X. So we know a couple things. We have bumper stickers, and we know that those are equal to $1. And we also have t-shirts, And those we don't know, so that's what our variable is. So we're just going to say shirts are equal to X. Now let's reread this and see how many of each she got. So it says the bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers. So how are we going to write that out as an expression? 1 shirt represents X, so I'm going to write X, plus, because she's buying more than one thing, and then 4 bumper stickers. Well, if the bumper stickers are $1 a piece, 4 of them will be $4. So I'm just going to write 4 in here. Now let's look at what her nephew wants. And her nephew wants 2 shirts, so 2 of these X's. So plus 2X. But no bumper stickers. So we could write in a 0 if we wanted to, or we can just leave it plain. So these are all of her costs. The cost of a shirt plus 4 bumper stickers plus the cost of 2 more shirts. All of that added up is going to get me the total, which is $67. Okay. Now I'm able to start combining like terms and just solving for X, which is the cost of 1 shirt. So X plus 2X is equal to 3X plus 4. Just carry that down, is equal to 67. Now I'm going to subtract 4 from both sides. And I have 3X is equal to 63. I'm going to divide by 3 on both sides. I'm doing opposite of what I see. Okay, so opposite of multiplication is division. That's why I'm dividing. So finally, I have X is equal to $21. So that is the cost of 1 t-shirt in this problem. Another step that we might have to add into our multi-step equations is using the distributive property. So if you see a set of parentheses with a number in front of them, remember we need to distribute. And when we distribute, we give that to everything in the set of parentheses it's next to. So in this first example, I'm going to send this -8 to the first term and to the second term. So that's going to get me -16x. Then I have a negative times a negative, so that's going to be plus 8 is equal to 36. Now that I've gotten rid of the parentheses, I can start solving like I would a 2-step equation. So I've gotten it down to a simpler problem. I'm going to subtract 8 from both sides, and I have -16x is equal to 28. Then I'm going to divide by -16 on both sides. Now, this is not going to give us a perfect answer. That's okay. You're allowed to have fractions for solutions. But what I want you to do is think to yourself, what can I reduce both of these by? 28 and -16 both have a factor of 4 in them. So to reduce it, my final answer is going to be 7 over -4. Don't lose your negative. And just leave it like that. Like it's okay to be top heavy. It's okay we have a negative, and it's okay that it's a fraction. Like that's all right. Just trust yourself. All right, for the next one it says 18 is equal to 3 times the quantity of 2x minus 6. First things first, get rid of these parentheses. So multiply by 3 on both sides, or to both of those terms, sorry. So I have 18 is equal to 3 times 2x is going to get me 6x. 3 times -6 is going to be minus 18. Okay, now this is like a 2-step equation that you guys should be familiar with solving. So I'm going to add 18 to both sides. Notice I'm adding because the opposite of subtraction is addition. So those go away. I have 36 is equal to 6x. Now I'm dividing by 6 on both sides. X is equal to 6. Okay, moving on with these examples. What if your original problem has fractions in it? I know, your worst nightmare. It's okay, we have a strategy to get rid of the fractions in the whole problem if you desire. There is more than one way to do this, like most problems. I'm going to show you the strategy of how to get rid of the fractions, but you don't technically have to, okay? So it says, if you want to get rid of the fractions, then multiply both sides of the equation by the lowest common denominator. The lowest common denominator is going to be the smallest number that 4 and 3, or whatever numbers that you have in your fractions, multiply to. So I'm going to say that one more time. To get rid of the fractions, you're going to multiply both sides, and notice we're multiplying by the lowest common denominator. Okay, so basically you're asking yourself, what is the least common multiple of the denominators? That's the question you're asking yourself. What is the least common multiple of the denominators? Alrighty. So in this first example, we have 4 in the bottom of our fraction and 3 in the bottom of our fraction. So we ask ourselves, what is the least common multiple that 4 and 3 have in common? If you struggle with finding least common multiples, then what you should do is just set up a table. So I'll label this finding an LCM, which is least common multiple for short, and you're going to start listing the multiples of these. So we have 4, 8, 12, 16, 20, 24. I'll just do a couple, okay? Then we have 3, and we have 3, 6, 9, 12, 15, 18, and 21. Now you're going to look for the smallest number that both of these have in common. Notice it's this 12. So that's how we know the least common multiple is 12. So I'm going to multiply the left side by 12 and the right side by 12 of this equation, because that's going to get rid of these fractions for me. So what you're going to do now, this 12 gets multiplied by this term, and this 12 gets multiplied by this term. This 12 gets multiplied by the 10. So 12 times 3x over 4, if you need to use your calculator, you may. It's just 12 times the top number divided by the bottom, and remember the variables along for the ride. So we have 12 times 3 divided by 4. That's going to get me 9x. Carry down my minus sign. 12 times, remember there's an invisible 1 here, so you can say 12 times 1 divided by 3, which is 4x, is equal to, then I have 10 times 12, which is 120. Okay, now this is a much simpler looking example for us. Instead of having all these fractions, I just have 9x minus 4x now. So I have 9 minus 4, which is 5x, is equal to 120. Divide by 5 on both sides, and I'm going to have x is equal to 24. Okay. Next one, I have 9, 6, and 3. So now I have more than one number that I need to consider what the least common multiple is. So if I need to, then I can set up a table once again, and I'll just start listing out some factors. So we have 3, 6, 9, 12, 15, 18, 21. And then here we have 6 and 12 and 18, 24, 30, 36. 9 is 9, 18, 27, 36. So I'm going to stop there because notice we have found a number that they all have in common, 18. I will circle those for you guys. I've got 18 in common with all three of them. So that means that 18 is going to be my least common multiple, or my lowest common denominator in this example. So I'm going to multiply the left side by 18, and I'm going to multiply the right side by 18. Remember, everything in the parentheses gets multiplied by 18. So 18 times 1/9 is equal to 2. 18 times 5/6 is equal to 15. Carry down my minus sign. 18 times m/3 is equal to 6m. Now I'm going to start isolating my variable. So I'm going to subtract 15 from both sides. 2 minus 15 is -13 is equal to, don't lose this minus sign, that's a common mistake. Keep that minus sign in front of the term, so -6m. Divide by -6, and we're kind of running out of space here. So a negative divided by a negative is going to get us a positive. And notice that 13/6 can't be simplified anymore. So I'm going to just leave it 13/6 is equal to m. All right. So here we had fractions. What if you have decimals? Now I know that yes, you can absolutely just type this into your calculator, that's fine. But if you want to get rid of the decimals, if you want to get rid of them, then here's what you do. You are going to multiply, once again, both sides of the denominator by 10 raised to the number of places to the right of the decimal point that you have. I will explain what that means in just a second, but first I'm going to put a little table over here and show you 10 to the first is equal to 10. 10 squared is equal to 100, because that's 10 times 10. 10 cubed is 10 times 10 times 10, so that is going to be 1,000. 10 to the fourth is 10,000. So this pattern just continues. So if you know a couple of these, then you don't have to write it as 10 squared. You can just write it as 100. So in my first example, let's say I want to get rid of the decimals. I don't want to use my calculator for the decimals. So what I do, I look to see, of all of my decimals, where does my furthest point go? So notice how in this one I have 2 points to the right of the decimal. In this one I have 2 points to the right of the decimal. So that means I need to use 10 squared. This 2 right here is corresponding with how many points to the right of the decimal I need to multiply this by. Or in other words, 100. So I'm going to multiply the left side by 100 and the right side by 100. I know that this one right here only has 1, but that's okay. I'm just going to add a 0 after that. So I'm going to multiply the left side by 100 and the right side by 100. Okay, what that does is it moves the decimal 2 spaces to the right. So now I have 350x minus, this one moved 2 is just going to be 2x is equal to, this moved 2 decimal places, is 124. Alrighty. Now I'm able to combine like terms, so 350x minus 2x is 348x. And then I'm going to divide by 348 on both sides. This is not going to reduce perfectly either. That's okay. They both, I believe, have a multiple of 4 in them. It might take you a second to figure that out, but I'm going to reduce both of them by a factor of 4, and that's going to get me 31/87. And that's as simple as that can go, so I'm going to leave it just like that. All right, my very last problem for you. Once again, look and ask yourself, how many decimals over do I need to move it? This time, it's only 1. So I'm going to multiply the left and right side by 10. Okay. So now my decimal just gets moved 1 over. That's my next step. So I have negative 23y plus 1y is equal to 34. Negative 23 plus 1 still stays negative. It's negative 22y is equal to 34. Remember, when the number is right next to the letter, that means multiplication. So the opposite of multiplication is division. So divide by negative 22. This does not reduce perfectly either, but they do both have a factor of 2 in them, so I'm just going to reduce it by that. And this is going to get me 17 over negative 11 is equal to y. And I'm done. We'll be doing a lot more practice with problems like this in class, so if any of it's tripping you up, you be sure to ask me questions tomorrow and the day after, and we'll try to get those, troubles taken care of. But until then, have a great afternoon.